in City of Kolkata for the last 18 years. He has already implemented various R&D projects focused on speech corpus development, uh, other projects like text-to-speech synthesis, automatic speech and speaker recognition, uh, language identification, emotion recognition, etc., etc. Dr. Basu has also executed research projects funded by central and state government as well, and also handled various business projects. Dr. Basu has authored over 50 research projects papers in prestigious national and international conferences as well as journals, which has already been published and praised by various authors and also been cited. We are very much fortunate that he has completed his PhD work under the supervision of our HOD, Professor Shanirbar Majumdar. Dr. Basu has also been invited to deliver talks at various institutes and national and international conferences, demonstrating the CDEC projects on speech technology. Furthermore, he has served as a reviewer for esteemed journals, conferences, book chapters as well. He is a senior member of IEEE and a lifetime member of Institute of Engineers India. So with this short introduction, I'd like to hand over the session to you, sir.
Yeah, thank you, Joyanta, for introduction. And it's really good to talk with the, I mean, with the whatever the participants are there. I think mostly most of the participants are the maybe research scholars, some masters students, or maybe there's some faculty members are there. So it's always nice to talk with you. This is my, I think in this similar, event I have once I have presented maybe 2 years back. So today's topic is basically on Python and WEKA tool for the machine learning. So just hold, I'm sharing my screen. Uh, so is my screen is visible to all of you? It's in full screen mode. Is it
Yeah,
visible?
yes, visible.
Okay.
Yes, sir,
Okay.
visible.
Okay. Thank you. So, and my voice is also clear to all of you. Hello. Yeah, I'm also audible to all of you.
Yes, yes, audible, sir.
Okay, okay, thank you, thank you. This differences is very, feedback is required. Most of the time before COVID, we mostly physically present but right now we are habituated with this online platform. Most of the time, we also prefer to the online because it's we can also do some activity others than the presentation. Like we are in CIRAC, schedule is very tight to working on different projects. Anyway, uh, so today's topic on machine learning using Python programming and WEKA tool. Though I think this machine learning term is already known to all of you. Many of the speaker already, spoke on this particular domain. So I will try to, less speak on that domain. Rather, I will try to more speak on Python programming and WEKA tool. What are the differences? Which tool is preferable for the researcher? For those who are doing research in the area of data mining, data analysis, data processing, any other area related with the data, natural data. Okay. So before we'll start, just brief 1 2 slides. I think all of you know the CIRAC. We in CIRAC we have 12 centers in across the India, and we have around 3,000 professionals, engineers, scientists in that area, and we are under Ministry of Electronics and Information Technology and carrying the research activity in the domain of ICT, electronics, and associated areas. And we are from, myself, I'm from Kolkata. So in Kolkata, we mostly working for the eastern and northeastern part deployment some project. Though partner center also with us, we tightly collaborate all other centers, and we will say that we will try to focus some deployable solution which will be really fruitful for the end users. For that means we all working in the CDAC. So mostly CDAC, in CDAC there are different thematic areas we work: high performance computing, HPC, multilingual computing, and digital preservation. Most of the thing whatever my I'm working in this area mostly multilingual computing and digital preservation. Other than that, embedded system, VLSI, software technology, force, cyber security, cyber forensic, healthcare informatics, education training. So these are the many areas in CDAC they are working. Uh, so I skipped those basic slides, about the CDAC. Uh, but today, as we are going to talk about mostly on machine learning, Python, and WEKA tool. So this kind of image is already known to all of you. Artificial intelligence, machine learning, and deep learning. All of you know that these are the in emerging technology area. If anybody is working in the area of data science, they must know about the machine learning approaches and artificial intelligence. And many of the students are also working as a machine learning as a tool, because it's very difficult nowadays to know each and every algorithm in the depth. um, and there are so many tools are available to working in this area. So so these are all the natural data. Data is very important. Everybody is think, without data we cannot do anything. Okay. Say like today I'm talking with you, and this conversation is recording by somebody. So these are the kind of video, audio, this data is also very much important for the analysis of any natural data. So in the left side corner is most of the audio data. And there are meteorological data like a temperature, rain, what is how much rain, weather information. There are so many data. Weather, then stock data is also very important. There are data like a facial, face recognition, video analytics. There are so many data is also available nowadays. And there are some data of identifying, like we would like to identify the number plates. So these are all natural data. uh, and without data we cannot do anything. Okay. So this data is very important for the researcher, whoever working in the different area, like maybe image processing, speech processing, IoT, audio signal processing, any natural language processing, any other area. So they must need some data. Without the data they cannot do anything. If we have the data, after that what we will do? So we need some tool. Okay. There are so many tools are there. Like WEKA is another tool, Orange is another tool. My earlier speaker speak on SPSS. Then if we have R tools, Python, MATLABs, Simulink is a tool. There are so many tools are available. Some tools are open source available. If we can use that at open source. Some tool we need to purchase. So there are different pros and cons are also there for every tool. But today we will stick on like a Vega and Python. This tool nowadays, those who are working in the area of machine learning and data science area, so they must use the Python as a tool. um, uh, and Vega sometimes we also use. So these are some references. It's these are some solution. Why this solution was this example I am giving to you? Because some of the solution backend is whatever we developed in Python. And some, obviously there are other technologies is also required, like any web application is required. So today those who are working in the area of Python, they know Django very well. So whatever the solution we deployed and we worked on, some I mean, some for the some solution we used Python also. This is one of the solution we deployed for the Tripura. We work for the Tripura blind schools. So these are the solution developed mostly in the Java environment, uh, Java Spring Boot environment. But the front end, some portion is I mean written in Java. I mean in Python. So there are some application area. It's a real-time application. Whatever I'm showing to all of you, these are the full-fledged project we completed in the area of data science. These are the also some very important application area for the farmers. Here the data is the commodity price information and weather information. I mean, just two slides before I have shown like weather information is also very important. So through this application, we also focus some kind of weather information. Whatever the data we crawled from the IMD website, we also, I mean, do some kind of analysis on those data, and we disseminate the information through an IVR solution. So for the farmers, mostly in the farmers. So these are the speech driven. Farmer can speak over telephone. They can give some query, and we immediately return back with some information. So these are the solution already are deployed, and in different parts of the India. They are using in different languages, not only in Bengali, but also in Tamil, Telugu, Hindi, Marathi, other language, other official languages also. We are doing in a collaborative manner with other institutions. So these are the application of the speech recognition and the data science, where most of the data whatever we have populated, and background we have written some scripts, either it's a PHP scripts or Python scripts. And I mean, if we know about some scripting languages, then it's very helpful to write any code. Python is a very powerful tool we use mostly for the data analysis and model building. So background of this kind of architecture, whatever we design, we call is IVR server. So most of the code is written in Python. Okay. So another, this is face recognition one example. That's this is an end-to-end solution whatever we already deployed in the Tamil Nadu police, and it's using currently the government of Tamil Nadu, police. And the end-to-end system we deployed with the Django framework, and MySQL and Postgre as a backend. So, and it's running perfectly well. So from the front end to back end, everything we have written in Python. So these are the, I mean, these are the projects whatever I'm showing to all of you. It's written in the Python mostly, with some other wrapper and other framework we also used, but the core engine, core part is also written in Python. Similarly, these are the another important project we have just completed 1 year back for the with the collaboration of NCSM, is a National Science Museum. This machine learning path we deployed and developed in the Python mostly, but other than Python, Visual Studio also we used for the front ending, because this is the desktop based application. So but the core machine learning path we developed in Python. Okay, so I'm not going to the detail. If you have any question on this project, you can ask. So you can stop me anywhere, I can give the detail about the project if you are interested. Maybe in the end of the presentation you can also ask. That's not a problem for me. So, and this is one of the important like optical character recognition. Most of the researcher and students, they do some kind of research in the area of NLP, and this OCR is another important area. So in the OCR itself, it's a huge consortium, a huge initiative taken by the government of India. In all 22 official languages, they are doing the OCR, I mean optical character recognition. All the whatever the Indian scripts are available, Devanagari, Assamese and Bengali script. There are different other scripts, all Chiki, so different other scripts. So whatever the scripts are available, so in every script, the government of India taken the initiative to from this. If you have the printed thing, you can be, I mean, it's a machine generated editable text we can provide. So these are the an important area of the research. And you also need to know that if you have good knowledge about on the Python, then the students or maybe the researcher can also be part of this research team or this development team. This is very important. I mean, the core machine learning part mostly we depend on the Python. Obviously, some pros and cons are there with the Weka. We will need to know just after some time. So this is one of the very important slide, Weka versus Python. Um, WEKA is very, very good user-friendly tool, good GUI. Is WEKA they have, and it's open source. Both the Python and WEKA, we can use. It's open source. Anybody can download and install and use it. Nobody, no license. You can stop. So you can do any kind of exercise. You can publish your lots of paper on WEKA. So it's a good user-friendly interface in WEKA, and it's a there are pre-built algorithms, machine learning algorithms also there. You can just use it as a tool, and there are different pre-processing modules are already available. So if you can do some kind of pre-processing with the data, whatever the data you have, that you can do. And so one, just only one point you need to know, it's a very simple to use. And if you have any idea in very short time, you can present your idea and build your proof of concept system. Okay, so if you have any idea, if you have some data, so immediately within a week you can generate some results. You can without writing any single line of code, using Vega, you can build your model. Okay, you can build your model, you can train the use machine learning system with the data, whatever the data you have available, and you can show some demonstration. So proof of system thing is you can do using the Vega. But whenever you are thinking about to some robustness and doing some real time work, then obviously we we need to depend on the Python. Okay, in my lab itself there are professionals, they are working mostly on the Python. And they not only know the Python is a one basic rule, basic language they need to know. Other than Python, they also need to learn different other scripting languages. Obviously some databases need to know how to interact, some front ending Django frameworks they need to know. So these are the all around the Python they need to know. And if you have some good idea about the machine learning, then you are really suitable to join any research organization like CETA. So I will say, so if you are the scholar, and if you have the data and you need to establish your model, or maybe you can say the performance you need to evaluate, you can go for the Weka, and you can build your proof of concept, and you can publish the paper, whatever the data populated results populated by the Weka. You can publish your paper. You can also mention that you use the Weka tool. That's not an issue. But if you are really working on a area like where the huge amount of data you are pursuing, and you are planning to have a bigger project in your mind, and need to for that thing, that time you need to work on the Python. You need to know about the Python. There are extensive libraries, scikit-learn. Some typos are there. Scikit-learn, TensorFlow, PyTorch, Keras. There are different and extensive use of libraries. We most every day we use these libraries in different way for our different machine learning purpose. And another point is that it's a very much flexible in nature. Okay, and the community support. If you stuck somewhere, you can just write in the community. If immediately they will reply what are your problem, okay, and how we can solve those kind of problem, how we can overcome those problems. Okay, so these are the different areas and differences between Weka and Python. As I mentioned, if you are planning to have a uh, mm, doing some kind of POC, just use the Weka, and within 7 to 10 days you can have some kind of results. You can demonstrate with the result with your supervisor, to your higher authority. You can present that these are the data. If you can do in a bigger way, you can get the similar result using the Python. If you check the accuracy, same data with the Weka and Python, most of the time you will say the similar result you will find. Only thing to need to think about the parameter tuning. So if you have the same parameter with the same values, the results you will get the very close result. Okay. Sorry. So any question up to that? Weka and Python till up to these slides. Do you have any question? Anybody you can ask me. Okay. So anyway, what makes Python the best programming language for machine learning? Because I already mentioned it's easy to use, and there are so many libraries are available: NumPy, SciPy, Scikit-learn, Keras, TensorFlow, PyTorch, and these are the built-in libraries. Okay, and it's a platform independence. Those who are working on Linux, Unix, Mac OS, or Windows, it's a, it's anywhere you can write the same code. Some basic thing is different. If you can write the code for the any, it can run any any operating system. And visualization is also available using Matplotlib. Seaborn is also there, so visualization is very important. You will get the visualization using different libraries that are available. And obviously I mentioned the community support. So most of the time we use the Python 3, because there are some, differences among Python 2 and Python 3. And currently most of the researcher are using like a Python 3.11 or 3.10. So we prefer to use, at least the version above, 3.6, because these are more stable Python. So I'm not going to the detail of the this kind of installation. It's a very easy to install in your machine. So these are the step by step information is available. What you can do for the Windows and Linux, so you can install the Python. Um, so just keeping these slides, and we prefer to work on Jupyter notebook, and also we prefer the Anaconda environment, because I personally prefer, if I working in the Windows or Linux, I prefer Anaconda environment to work. But within Anaconda environment, obviously I use Jupyter notebook, as well as Spider I used, because sometimes Spider is more useful. But Jupyter Notebook is very good for any kind of when we are going to demonstrate to any forum. We prefer to Jupyter, because it's self-explanatory. Each and every step with some every step we can explain. So so nice. For the demonstrate to any students or researcher. So we prefer Jupyter Notebook at that time. Today I have some some example with me, so that is also on Jupyter notebook. Okay, so I'll come that portion also. So we also prefer to use the Google Colab. Okay, because in Google Colab, if you have the data, so you may run in CPU, GPU, or maybe the TPU, because you know the this GPU card, graphics card is very important to run neural network, deep neural network. Because if you have lots amount of data in like image data or video data, so you need the GPU. Without GPU cannot. But it is not possible to any single person to purchase GPUs for his or her research purpose. So we prefer either use the institutional resource, or maybe sometime we use this Google Colab. Okay, in the Google Colab, at least you can use their GPUs and TPUs, though there are some limitations are there to use GPUs and TPUs. But if at least if you have a good amount of data, like if data like a textual data around 10,000 or maybe 50,000 data you have, it's not a problem to process for TPU in Google Colab. But in CPU, it will take so many time, and there are so many problem may occur. Your CPU may be heated, and it will take maybe uh, 3 days, 4 days, or maybe 7 days it will take to process CPU, but it's a very difficult to open our laptops or maybe normal desktop to open 7 days at a time. So we prefer to use Google Colab GPU and TPU at that moment. And if you have the subscribe version, I mean license version of the Google Colab, so then you will get the enough freedom to work on the TPUs. So that is also possible in a bigger scenario. But most of the cases we have seen, like if you have data, quite a good amount of data, and those data is not working in your CPU, you can just go directly to the Google Colab and um, I mean you try to use their GPUs and TPUs. It's working absolutely fine. It's not a big problem to work with these TPUs. So these are the in general machine learning workflow. Without data, we cannot start. So first of all, we need to find out the data. Data means I already mentioned, if you are working in image, so image data, video data, audio data, textual data, maybe any data. So in which area you are working, so those data is important. Like in OCR, like a OCR printed data is also important. So after getting the data, we need to clean, prepare, and manipulate with some data. So there are so many, errors are there within the data. We need to clean it. We need to do some kind of pre-processing. Okay. And sometimes there are so many data is not available, so we need to manipulate to generate, synthetically generate those data. So there are so many mechanisms are available, in both in WEKA as well as in Python are available. So it's not only for Python, it's both the in both the system. I mean, for the WEKA and Python, for the both the tool, you can use this manipulation, cleaning and pre-processing is possible. So after that, if you have a good amount of clean data, good data, you can build your train model. Then you are doing some kind of validation, uh, and to improve your system with fine tuning some kind of parameter, or sometimes because it's hyper parameter. Some parameter we need to fine tune, and we rerun again and again and again to and check what are the accuracies coming. And if you are getting the steady, good accuracy, same time with the different data, there are different options are there, like a 10-fold testing, or maybe the trend test split, like 80-20 splitting you are doing. So there are different approaches are available in the both are Weka and Python. So after getting some improved data, when you satisfied, like whatever the data you have, you are getting the good result, you can save the model. Whatever the trained model you have, you can save the model, and you can reuse those model for the inference purpose, like for the final testing or unknown data testing purpose. So these are the common machine learning flow. Though there are different other sub modules are also there, but these the basic flows we will say. Mm, these are some examples I mentioned. So if you have some not available data, so if you see here, here in salary, some blank, sometimes is uh, maybe this data is deleted some way. Okay, whatever the data I've received with the no salary is there, so we need to generate those kind of salary. There are many procedures are available, mean interpolation, some data, there are different averaging procedures are there. So there are different procedures that we can all either we can discard those data, or we can just manipulate those data for the for the machine learning purpose, training purpose, that we can do. Okay. So mostly, in the broader way of machine learning, you all know that supervised, unsupervised, and reinforcement. These are three type of algorithms we need to learn. Within supervised learning, regression, classification, and unsupervised, like clustering and dimension reduction, and reinforcement learning. So these all the thing is required. We need to find out what are my problem statement and which approach is suitable for me. If it is a regression problem, then we will try to use all the regression, whatever the algorithms are available, machine learning algorithms are available, that we will use. If it's a classification, we will use those classification algorithms. But if we are planning for the unsupervised learning, then clustering we will do. So it's depend on your problem statement. We need to find out what is my problem statement and how we need to attack those problem statement. Okay, so these are some examples of supervised learning. Simple, regression problem, where the simple a linear regression kind of problem is just kind of straight line we can plot. We need to find out some, some kind of regression line we can plot. So this is very simple to write any code. Maybe I can show you some demo here also. So anyway, I show you demo after my this theory portion is over. Okay, so I will show you this simple linear regression, some demo I have to showcase with you. Similarly, if you have the, scenario something like if you have multiple data, R&D spend, administration, marketing spends, different data you have. If suppose you have the group of angel investors when to invest their money into different startups. So, I mean, if we are using the multiple linear regression or not, it is depend on the problem statement, because problem statement is very important. You need to find out the which regression is important for you. We will go for the linear regression or the multiple linear regression. That's depend on the problem statement. Okay. Similarly, for the classification is a simple classification problem. So two class problem. We need to zero and one. We need to identify what are the two classes. So there are different algorithms are available for the machine learning. So we need to write some code for the Python and identify the different two classes. Though it's not possible to get the 100% accuracy, sometimes some data it's what we'll say. Sometimes some data it's not good to fit. Some data is erroneous data. Like in the picture itself, we are showing that there are some green dots that are also available within the green blue. Red dots are available within the green dots. Maybe those data is may not correct. Okay, so we need to we need to clean those data if possible. If we can know the these are the overshoot our criteria, then maybe sometime we need to clean, and after that we need to try different classification. That's why the pre-processing itself is very important. So you need to work on the data, whatever the data you have, you go through the data and identify the pattern. So you need to run the pattern many times, then go for the classification problem. Okay. Similarly, this is another this supervised learning for logistic regression. So I'm not going to the theory portion. Okay, I will go for the demo for you. Just skipping this NAPE. This is also the NAPE based classifiers. And this is for the supervised learning for classification, different classification approach. We can. This is the banking customer data. It's a very useful data. This data is some data is also available in in the website itself. You can in the Kaggle site, you can go there, you can download this kind of data, and you can just play with this kind of bankers data, bankers information. Those the data is there are different columns, different parameters are there, so you can play with those data. Bankers data is available in the Kaggle. So you can play with those data and use different classification algorithms, whatever available in the WEKA or maybe in the Python. And this is very important artificial neural network approach. Most of the things started here. Every researcher saying like, we need to work on the deep learning, deep neural network. But before that, we need to little know about artificial neural network itself, so that we can have some basic knowledge about this neural network approach. uh, this is the k-means clustering, basically part of the unsupervised learning. So if you have data but you don't have any idea that what is the value of k, we need to find out the how many different cluster is possible. So that time we will find out some kind of centroid position using k-means clustering. So it will try to find out the centroid position within the data. If there are like a five in this figure, like there are five centroid, we can find out. So we can say there are five clusters. Five clusters are available. 5 different clusters are available. Okay, these are the 20 different Python source code already available of the different in the GitHub. So if you just go and search in GitHub, so there are end-to-end system is already written in the Python. Source code is available, data is available. So you just download the data and you run whatever they have given. So at least you will get some basic idea about the Python and the data. On top of that, you can just uh, do your own research on the data whatever you downloaded. Okay, um, so if you see here that like TensorFlow is the most of the users, most more than, I mean, contributors, more than 1,000 contributors contributed in the area of TensorFlow, scikit-learn. So you can also, I mean, you can download those application in the from the GitHub and you can try. Okay, so anyway, after this WEKA will come. So before WEKA, I just try to give you some example in notebook. Jupyter. So I like open my Jupyter notebook first. So I think my screen is visible to all of you. Is my Python script is visible to all of you? Uh, Hope it's visible. I mean, hope it's visible to all of you. It's a part of the data processing tool. So I try to zoom it so that you can have some good look. I mean, first of all, I imported some libraries. You all know that import NumPy as NP, Matplotlib, and these pandas, and then importing my databases. There are some databases already there within my data.csv. So within that data, I've just printed those data, and this is basically France 444.0. What are the values are there? Okay, this Spain, some numbers. Okay, so some data is already available, and these are kind of our classes. Yes or no is a two class problem. Okay, so handle some missing data. If you see some missing data is there. Okay, so in the Germany there is no, and this price data is available. So we need to find out what is the data. Okay, so missing, we need to like a simple what we say imputer we will use here. We're using some mean. So we are actually creating some kind of average and try to fit. And if it is some NAND data is available, then it will fit. Okay, so similarly we have computed, manipulated this data. So we have done the finding some missing data. So if it's a very less number, then only we can do that. But if you see that within your data there are so many missing data, it's very difficult to do. Then we will say that we cannot do that, because if we do that, maybe we will say it's a bias in nature. We cannot do. For that time we need to, rework on the data again, and then we will do. And after that, this step is encoding of the independent variable. Independent variable is basically what are the input data, this x value, these are all independent variable. So if there are some categorical data, like here itself France, Spain, Germany, these are the names, so categorical data. So we will do some kind of column transformer, and we will use, and we will give some kind of numbers. Okay, against the name, for this France, Spain, Germany. So we will be, happy if we can deal with some number. So in the Python, mostly we will do this way. These are the part of the pre-processing. And also we will do some kind of encoding of the dependent variable. This dependent variable is basically the my y values. Yes, no is written here, my y value basically no, yes, no, no. So this 0 1 thing we will prefer most of the time. So we will do some label encoder here. So it's a very easy to just import some scikit-learn pre-processing import label encoder and write just one liner code, and it will give you the new y value. Okay, new y value, it's a with 0 1 value. Okay, then we will do kind of splitting train and test. So most of the time we prefer to split 80% for the training and 20% for the testing. So after this importing this train test split from scikit-learn, so we use this split this our x value and y value, and test size is 20%. I mean that means the 20% data we will use for the testing purpose, and 80% data for the training purpose. So, and it's a the data is available within the x train, x test, y train, and y test. These are the output of this train test split. So after that we will get our train data, test data. Okay, so then we will do, sometimes it's not all the times, we will do some kind of scaling. Scaling is important because whatever the data we have, it's a different range. It started from zero, maybe it's going to 1,000. Sometimes it's starting from 500, it's going up to 20,000. So we will do some kind of scaling, so that every time we will say this data should be come within some span. Okay, some minus say -5 to +5. So whatever the data we have, we will say that we will be happy to be my all data should be in a normalized format. So we will do the standard scalars. So we, most of the time we will do this scaling approach. So these are the very standard approach. Other than this, there are so many other approaches also there, but most of the time we will do this kind of scaling for the features. Okay, so these are the sample code. If you download any source code from GitHub, you will find out these are the basic steps they also followed. It's a nothing new for you. You can just download any source code and run on the Jupyter notebook. You will find these steps are already available. So my only request to all my scholars and students, and those who are doing research in the area of the data science, or maybe the using some kind of data for any manipulation, building the model, these are the basic steps need to follow. Okay, so these are the pre-processing. After the pre-processing, so if I have any regression problem like linear regression, so what I will do, first of all I will do the this splitting thing, everything we will do. Okay, similarly here itself, like I import my salary data, and this data is already scaled data. So we will do the this train test splitting. Test data is 1/3 of the testing purpose. There are many way we can write. So we will do the we will import linear regression from the this scikit-learn linear model. Then I just fit my train data, I build my model, and it's a simple this regressor dot predict, it will predict my values. Okay, so these are the straight lines. Okay, it's a try to fit and reduce the whatever the errors are there. So this line is fitting in such a way that it's a errors are very less, minimizing the errors. Okay, uh, so and for the test data, this is for the train data, and for the test data, so same kind of fitting we same algorithm we can use for the testing data itself. So these are the simple linear regression problem. Apart from that, I have the code for a simple classification also, like logistic classification. Okay. Mm, so approaches are very same, only you need to write maybe 2 3 lines are different. Every time you need to import your numpy, matplotlib for plotting, pandas for the data reading. So here also pd.read.csv, I have reading some csv file. Okay, comma separated value, and taking all the values except the last one. Okay, for my x, and for the y, my last value I'm taking is only the last value as a y value. So and after that we are doing here again test splitting. Then here feature scaling, in the last example also in the pre-processing we have done that standard scalars. We use the same standard scalar we use to scale our training data, because we will be happy to if we have the data within the in a fixed range. Okay, if my data is starting from -10 to -50, or sometime -30 to -200, will be preferred to have my data in a single span. Okay, say -5 to +5. Okay, so they will generate the data. Okay, you did not bother about the data. I mean, just you will apply the standard scalar mechanism and fit for the transformer, so it will generate for your train data as well as text data. Okay, here itself we have done the, so this is for the standard procedure. Okay, after this regression, what we have done, this logistic regression we import, and this classification, this is only for the definition, and we use for the, this is the fitting. Xtrain, we have given the xtrain as an input and ytrain as an input, because it's a supervised learning. We know the y values. If it is for the x, I mean some value is the array, x is the array, and y is basically one data, for the class data, name of the class. So we are doing the classification. We can also, I mean, save this model. If we required, we can also save it. And after that, we are doing the predict the unknown data whatever we have. So if this is my unknown data, will they will give the I mean this class output. Okay, so this way we can do, I mean we can also generate my confusion matrix from the whatever the data we have. And for the visualization purpose, there are many algorithms are available. So we are visualizing in this way. What are the red dots and blue dots are here? These are the, these red dots are maybe some errors are there. So that's why we are not getting the 100% accuracy, maybe sometimes 95-96% accuracy, because of the data. I mean nature of the data is dependent on the data. Otherwise, I mean as I mentioned earlier, that either we need to have the good knowledge about the data pattern itself, so that we need to identify and eliminate the noisy data, or need to remove those noisy data. After removing only, we can work on the actual data, whatever we have. Okay, so these are the visualization. There are many visualization things available. So this is the purpose of the visualization I have done. This is red dots and blue dots of these are the regions, and these are the some errors. Okay, uh, okay, let me see what are the different some clustering, k-means clustering problem also I have for you. Mm, so here I mean some data, see again I have input. I mean if you see the I mean first few lines of any source code of python, they mostly import some kind of this libraries for the reading, and whatever the application we are, I mean this kind of calculation we are doing na. So for that we are importing some. For this k-means, we have just import scikit-learn cluster k-means, and we use this k-means algorithm. This is what are the random states, and after that this k-mean is fit for x10 values. And then we have done some kind of inertia thing to for the basically this is for the plotting purpose. We use how this data is plotting. I mean, and I mean, if the number of cluster is increasing, you are seeing that my performance also. I mean, sometimes it's a slow and steady. Okay, it's a parallel to the x-axis. Maybe that time we can stop it. Okay, so this way we are doing this kind of algorithm, and this way we are plotting itself. So you can run this code. This is also k-means clustering, very known I mean known code we are showing to you. So you can do that. So these are the very important I mean basic thing for the machine learning. If you need to know about more about deep learning, there are so many I mean code, I mean libraries are available. Mostly we are using pytorch, keras. So you can also do that. As I mentioned, most of the research scholar, they are mostly using the TensorFlow. So they are downloading the codes, I mean this solutions and the data for the TensorFlow to learning the TensorFlow. So you can also do that. So I'm going back to the this my my presentation slide for the WEKA. uh, better to show the WEKA, I will just demonstrate to WEKA. It will be clear more. Okay, so I just opening my WEKA. So WEKA is the free and open source tool. You can download your WEKA. Okay. um, so this is the WEKA tool. WEKA, you, all of you know this. WEKA is basically one name of the bird in New Zealand, and this is one um, WEKA tool is developed by the this University of Waikato in New Zealand. So they developed, it's a free and open source, and it's a, I mean, long back. It's a started in 2003 4, I think so. So researcher from since then till date, this is not obsolete. Sometimes some students who is coming in our lab, we have given some kind of assignment to doing some kind of I mean a problem statement, and saying that you do it in WEKA, because in the WEKA you do not bother about uh, your what I say, you did not write any code. Okay, so you just feed your data. Just I'm showing you something here, like I explore. Mm, so here some pre-processing, classify, cluster, associate, and select attribute and visualize. So from I need to first open my some data. So WEKA, they have given some data is already available with the WEKA. If you install, it will come with the this WEKA package itself. Say these are the different data. Okay. So say I open one small data for you. This is called the CPU data. Okay, so if you see this, these are the different MICT, I mean min, max, cache, then ch min, ch max. These are the 6 different parameters, and this is the class. Okay, these are the different classes value. Okay, if you see, if I select one parameter, it's a showing minimum value and maximum value, then mean and standard deviation. Okay, so I'm not doing, I have not written any code, but the tool itself is showing different values. So it's, my screen is visible, I don't know, it's a very small values is showing here, but if you see carefully, there are different minimum value and maximum values there. Okay, if you click here, each and every time, this is for the minimum value 64, maximum value 32,000. Okay, for the m max is maximum, minimum value 64, maximum value 64,000. Cache minimum value 0 and maximum value 256. So this is a different range. As I mentioned, we don't prefer different range wise data, we always prefer to have the data in a single range. Okay, so we can also visualize all the data whatever you have. These are the all data. Okay, these are minimum values, some maximum value, minimum and maximum values you can visible here itself. These are all data pattern. Okay, so what we will do first, we will do some kind of pre-processing. Okay, so for that purpose, we will go to choose some filter. Okay, go to the filter and do some attribute, some normalized filter. I mean some normalized, we will do some kind of normalization. Okay, so I choose some filter normalization, and I will just apply. Okay, so I just apply. After the application, you will see the minimum and maximum value. Minimum value is always 0 and maximum value is always 1. Minimum 0, and so I mean system itself generating the data in such a way that minimum value and maximum value within 0 to 1. Okay, so each and everything, the value is already within 0 and 1. So it's a kind of scaling. Okay, or maybe the normalization, pre-processing, whatever we have done in the Python, same thing we can do here using different this normalized filter. Okay, so and after that, this thing is over. Maybe we can go to the classify, and there are different options of the classification. So we need to find out cross validation is a tenfold class. What is a tenfold class? Tenfold class is basically whatever the data you have. Okay, just go back pre-processing. uh, Let me show you one another thing. Mm, these are all data. Mhm. So just show. these are all data. I mean, 209 total number of data is available, 209, and total different attributes 7. Okay. I mean, I don't have in this data is very small amount of data, only 209 data is available. So this 209 data is equally divided into 10 folds. Okay. uh, 10, what is the meaning of the 10 folds? 10 folds is basically 9 folds, 9 data to be used for the training and 1 data for testing. And in the second iteration it will take another 9 data, 9 fold, and 1 fold for the testing. In in the third run it will take different 9 fold and one data, 1 fold for the testing. So it will run 10 times for you. Okay. The system will run 10 times for you, and it will select data in a random manner for the 10 folds, and it will select one by one 9 fold data for the training, 1 fold for the testing. So what I will do, I will choose some kind of classification, like a function. Say I have some kind of linear regression. So I choose the linear regression. I have not modified any parameters. These are all default parameter. I can modify. These are called the parameter tuning. So maybe I just leave it for it now. But you can also do that. I mean, you can also play all those parameter. You can just change. So what I will do, I will click the linear regression and click on start. So immediately it will show you the whatever the data. I mean, total 209 data is available. So correlation of the coefficient is a 90%. You will say 90% accuracy, you can say. Mean absolute error is 41. Root mean square error, there are different errors that they are showing. Okay. So simply we will say this is a cross validation of the 9 folds, 10 folds, sorry. 90% accuracy we achieved. Similarly, we can also do like a train test split, like in as case of Python 80/20. Same thing we can also here do that percentage split, 80% for training and 10-20% for the testing. Similar linear regression we can choose in the percentage split we are doing. Click start, and it is showing the performance around 91%, 91.86. Okay. For the 10 fold it's showing around 90%. For the linear regression, the percentage splitting, it's showing 91%. Similarly, I can choose the different like different classifiers. Like here I can choose say random forest. Okay. Random forest. Random forest I choose, and cross validation of the 10 fold cross validation I choose. Then I click start, and after that it's showing correlation coefficient is the 95. So it's a good accuracy than linear regression. Okay. Classifieds, so 95% accuracy we achieved with the whatever the data we have after the 10 fold cross validation. Understand? So this way I have not written any code of the random forest or linear regression as I have done earlier done in the Python. So it do not bother about this thing, you just run it and you can have this data. You can also save your model. So you just right click on, you can save the model in your desktop. You can also load it for future use. And because I right now I have only 209 data. But if you have like a more data, like a 15,000, 20,000, maybe 50,000 data you have, so it will take little more time to I mean train your system. Okay. So you can at that time you can just save it the data and save the loop and save your model. And during this kind of identification you can reuse using the load those that model. Okay, that is also possible. So using this WEKA tool, you can, I mean, do classification if it's a classification problem or maybe regression problem, or if it's a cluster or maybe unsupervised problem, and then you can go for the clustering. But in our case, CPU data is mostly the clustering, I mean, classification problem. So we have done the classification. Similarly, you can use the different other, I mean, classifiers, any classifiers. Okay. Say for the from this function I choose multi-layer perceptron. Multi-layer perceptron is basically that our basic neural network, artificial neural network with back propagation algorithm. Okay. So with the multi-layer perceptron with the cross validation we start, and we achieved 92%. Okay. For the random forest we achieved 95%, but for the multi-layer perceptron we achieved the 92%. But we can do some kind of this different parameter we can tune that, and maybe sometime we achieve little more accuracy, that is also possible. Okay, so as time is limited, I will not showing that, I mean, this parameter tuning thing, but I will say that you can try at your lab with your laptop. This, you can install this WEKA tool. There are so many tools are available, I mean, so many this data is available, you can play with that data, and after that you can build your own data. But one point I like to mention here, the data representation within this whatever the data file is little bit different. I just show you again in my slides. There is one slide, uh, data manipulation, where it is, this, that data is important, that slide. Mm, okay, these slides, this is little important. If you cross check any data na, um, uh, just a minute, I can remove it, not an issue. Okay, so this is we call it the ARFF file format. Initially we will have like a relational, some relation. Okay, some attribute. Like attribute is basically we have age is the parameter. Okay, age is basically numeric. Value is the numeric, and then sex is basically male and female. Is that, I mean, these are some string, okay, string information. And then it will come the chest pain type, different type, what are the different type of the chest pain, that is also written. Then cholesterol, it's also numeric, some values will become at when we will talk about the cholesterol value. Then exercise induced angina, so it's a no, yes, yes, no. And then class is basically present or not present, it's a two class problem. In below, when the data will start, it will write 63. What is the 63? Age is 63. Then after that, sex is male. Okay, then chest pain is type angina. This is basically the chest pain. Okay, then 233 is the cholesterol value of the cholesterol. As we mentioned, cholesterol is a numeric. 233 is a cholesterol value. Then no when exercise induced angina, it's a no, yes or no, it's a no. Attribute class, present or not present, or not present. So these are the class types, so you can create your own data. Okay, so if you are working in image data, image classification, so you can populate your own data. Okay, um, and mm, and you can do the wake up. So here also in the, like in this data, there are in the fourth column, you have seen there again the question mark is there. The female, not Angela, this cholesterol value is not here. Okay, it's a question mark is there. What is the question mark? That means this the error data is missing. So we need to do some kind of pre-processing whenever we will do the WEKA. Okay, with some normalization algorithm we will try, and we will populate or manipulate this cholesterol value of this female candidate with the age of 30 to 38 years. Okay, understand my point? So this is the data file format is very important to learn. So if you have the idea about the data format of the this WEKA, this is only the new thing you need to I mean cross check. You can go, and similarly I just show you the natural data also, whatever I have with me. Just a minute, give some 5 minutes. um, okay. Hmm. Say this is my CPU. Where is my CPU? This is my CPU. I just open with Notepad or Edit Plus. I just opened the data in this. I think my screen is visible now. Data is visible. These are the attribute. Okay, these are the attribute. Relation is CPU, and these are the attribute. MYCT is a numeric. MMIN is a numeric. MMMax is numeric. These all are the numeric values. These are the definition, and after that they are providing the data. These are the input data. So you need to go through the data fast. If you have any kind of missing data, if you find any missing data, you can write the code also. Okay, you can find any missing data, you can interpolate, or you can do manipulate those missing data. So that is you can do. So I will also show you another very important this thing, data on iris data. Okay, this is the data. Okay, this is the iris relation, basically iris. This is the iris name of the database itself. This is the iris data, and what are the different values. These are the real values, and these are the different classes. One, two, three classes. This is the three classes problem. Okay, so these are three classes problem of the iris data. What is the type of the iris? Okay, so I will say that before you start to work with WEKA or maybe the Python, just go through the data fast, look at a glance. So if you find any any problem or any data variations are there, so basically how much you will do with the pre-processing. So that is a very important. If you have the good pre-processor for data, data manipulation, or maybe I will say the data training. So if you have the good pre-processing unit, you will have the good model. Okay, so pre-processing and data visualization is very very important for any this data related problem. Okay, so that's it from my side. I do not have much more slide, only this thing already I mentioned, is whatever the WEKA is. So in conclusion, we will say the machine learning is an astonishingly powerful tool. When data driven problem come into the picture, the machine learn the inherent pattern from the data and tries to predict the unforeseeable features. In the coming years, it promises to help solve of our most processing. I mean whatever that, what I think daily life problem, it will solve all the daily life problem. So I think that's all from my side regarding little bit on the Veka and small portion of the Python. So maybe sometime we can take also the hands-on session uh, to all of you. So that will be great to do some hands-on session. So for today, that's it from my side. If you have any question, these are some references. You can ask me. I will try to answer the question if you know the answer. Otherwise, you may just mail. You can contact in my mail ID. I'll try to give you answer. Okay. Okay. Thank you from my side. If you have any question, just ask me.
I think one of the participants has asked, where can we learn working of this Weka tool from? Any recommendations?
Weka tool is a free and open source. Just go to Google and search, like, write Weka. Nothing else. You just, if you need to learn more about the Weka, go to YouTube and write Weka. Nothing to do. It's a very simple, and I can say you within 1 hour, or if you can, uh, study one or 2 hours maximum, you can start working with the Weka. It's a very simple and it's a useful GUI and interactive GUI. So it's a very easy to learn. Only thing is that you will have little knowledge about the data and the problem statement. If you have the knowledge about the problem statement, you can start. If you know that this is the problem statement of regression, we need to find out some it's a regression problem, I will do some kind of regression. So if you have basic machine learning knowledge, then you can start working on the Weka tool. If it's a classification problem, just there are different classifiers are available, just choose it and play with the whatever the algorithms are available. So you did not learn about in detail the this all the classification, but I will say the this parameter tuning is very important in this area. I mean, in the many journal and good conference also, there are many papers they are publishing with some different data, and they are using the same approach, same machine learning thing, same deep learning thing, but they're doing some tuning in the parameter level, and they are getting good result from the baseline system. Okay, because baseline system maybe they achieved about 90%. If some researcher can think and do some kind of parameter tuning and do some kind of pre-processing, okay, good pre-processing with some novelty, because we need to give the reason why this pre-processing, this extra step we have done. Okay, and we have we achieved like a 92% 2% gain. It's a very good sometimes. So they publish paper. So using WEKA tool itself, you can do so many research and publish your paper. Uh,
Okay, sir, I think the same participant wanted to know about Google Colab.
okay, Google Colab is basically um, as one tool through which you can write your Python code. Google, if you have the Google account, then I mean, you can open your Google Colab account itself with the same account. Okay, so you just write Google Colab. Um, uh, can I show you again? Just share my screen. So if time permit, I can just. So very interesting. I mean, it will take not much time. So I think my screen is visible. So I will type Google Colab. Okay, the Google Colab. Welcome to Colab tree. So it will. I just click it, and it's coming some screen. Welcome to Colab tree. This is the Google Colab this page. Here you can write your own code. Okay, just go to file and new notebook. So whatever the Python code you need to write, so you can write here. So this is the platform, like we need not worry about to install Python and or so only you need to write your own code, nothing else. So it will take some time to for the connecting. So if I'm using some CPU, so it will connect to my CPU. They will allow this. It's a Python code, so it's my output. Okay, so I can write some text here. Like this is my, okay, where it is, just a minute. Code. This is my past Google Colab program. Okay, so this is my, I can bold it. So this is, so that's it. So I can so this is my I am writing my Google Colab thing. Like I can assign 5 here, then I can assign again 7 here. I can say print C. Before that I can maybe C A plus B. So this is my answer. Okay, so I'm writing any Python code using Google platform, and without installing Python in my machine, without I mean using my resource. It's a cloud resource. I can save it and keep it in the Google Drive. Okay, and I can show you here this the session where it is start interrupt run selection where it is sorry just a time change runtime here here it is. Currently it is using my CPU but not my CPU, it's a CPU of Google, and I can use GPU T4 GPU, and I can also use TPU. Okay, so these are very costly. If we can need to procure our own GPU graphics card, I need to NVIDIA graphics card and install some machine. It will take little more time and not good for any single researcher, but any institution. I think Tripura University also they have their own GPU machines are available for the processing. But Google is giving the same for free. It will not charge, only you will have your own Google account, and it will open. Okay, so that's it. I think I answered the question. So any other?
Yeah. Any other query from any participants?
Some raise hand from Kalidas. Do you have any questions, sir?
Kalidas Sharma, do you have any query?
No queries, sir.
Okay.
Thank you.
Okay,
Thank you very
okay,
much.
okay. Thank you, sir.
Okay. So with this note, I'd like to thank you again for sharing your valuable time as well as your expertise. And I'm pretty much agree with you that more hands-on session would really help the scholars and PG students.
Right, exactly.
Actually, we thought of this in offline mode. However, due to some technical or maybe administrative issue, we need to make it in hybrid mode. So, but within this constrained or limited platform, whatever you have shown, I think that it has already enlightened the students with the preliminaries, and I guess the student will now can start with this platform without any hesitation. So thank you,
Okay.
sir, for your time,
Thank you,
uh,
thank you.
and I think we can close now.
Okay, thank you, all of you. Thank you.
Okay.
Bye.
Yeah.
Thank you, sir. Thank you.
Thank you, all the participants. I think we can call the day and we'll meet you again tomorrow.